Alright, so this example, or in this example, we're going to create a stream of infinite factorial values. Now, again, we're going to use the big integer class to represent arbitrarily large integers. So, if you do not understand big integer, then you should go back and watch the previous video. Okay? So what I've done here is I've created a factorial method that receives a big integer and it returns a big integer. Okay? But there's sort of an issue here with how the stream.iterate method works. So it receives one big integer and it will receive, sorry, my cat just jumped in front of the camera. So it receives a big integer as the seed, which we might think to be 0. But then the lambda expression that we give it will also receive a big integer, and then it returns another big integer, right? And then this big integer is the thing that gets passed to the next invocation, right? So the kind of issue here is that we're going to get, so let's just try and get the, let's get the first 10 factorial numbers. The problem is that we're going to get 0, and then we're going to get 1 across the board because we're trying to, okay, my cat's going to jump in front of the camera again. The problem is that we're trying to compute the factorial of 1 each and every time, but rather we want to compute the factorial of the previous or of the next number. Okay, so but the bigger issue is that we can't do anything other than pass a seed and then a unary expression. Okay, let me pause the video. Let me get my cat down from here. Okay, he's down. Okay, so there's sort of a problem here. We really want to do something like this. So, okay, let me just repeat the problem. We cannot pass multiple things to this iterate method. Okay, or rather, by pass multiple things, the big issue is that we want to compute the factorial of the n plus 1th number, right? So we'd like this to compute the factorial of 0, then 1, then 2, then 3, so on and so forth. The issue is that we can't really do that with this approach. But what we can do is mimic this approach via using arrays. Now you may think, what in the world do arrays have to do with this? Well, let me show you. So, hopefully you would agree that the 0 factorial is the value 1. I think we can all agree with that. Then the factorial of 1 is also 1. The factorial of 2 is 2. The factorial of 3 is 6. The factorial of 4 is 24, so on and so forth. Hopefully you see what's going on here. We're using a 2-element array where the first value increases by 1 with each iteration, and the second one the second index, or rather index 1, the first element represents the number that we're computing the factorial of, and then the second element corresponds to the factorial of that number. So this would be fact of 0, fact of 1, 2 factorial, 3 factorial, 4 factorial. Okay? And what's good about this is that this is a single thing, right? This is a single, like, unitary value, right? So we're not passing two things here. We're actually just passing one thing that can store two things at the same time. So what would that look like? Well, the initial value, or the initial thing that we pass, would be a new big integer array that has the values big integer 0 and big integer 1. Okay, those are the starting values. And let's put this on a new line just so it's easier to visualize. Okay? And then what is the lambda expression that we're going to give it? Well, it needs to be something that receives, I really hate the way this gets formatted, but that's fine. It's going to receive, I'm going to call it a big integer pair. Okay, so it receives one thing, a big integer pair. And then what we're going to do, we're going to actually return a new big integer pair, a new big integer array, where the two elements are as follows. They are the, so remember, BIP is this thing, or rather, BIP is this whole thing that I've circled in this reddish color, this dark red color, okay? BIP at 0 is this number. BIP at 1 is this number. So what we can do is create a new big integer array where the first thing in this new array is BIP at 0 plus 1, and then BIP of 1, the factorial of that. Okay? So let's see what that would look like. So we can just do BIP at 0 dot add 1, and then BIP at, sorry, not add 1, big integer dot 1, and then BIP, so we're going to compute the factorial of BIP at 0. Okay? Now, you may be wondering, why is this not working? The problem is that this thing expects a big integer return. This expects a stream of big integers, but we're trying to work with big integer arrays. So we actually need to fix this to say that this is a stream of big integer arrays. Okay? Now, if we run this, we're going to get this. Yeah, so this does not look very nice. Okay? So, and this should be BIP at 0. Yeah. Okay. So the issue here now is that we have a stream of big integer arrays, and that's not really what we want. What we want is the first value from that array. So there's a method that we can use that will get us that value. So we're going to get the first 10, but then I want to use this method called map. What this is going to do is it will receive something of type big integer array, and then we're going to map it to big integer array at 1. Okay? So remember, this is a stream of big integers, so we have a stream of things that look like this, right? This is our big stream. So what we want to do is create a new stream where we only have big integers that are these values right here. Okay? So let's see what that looks like. So let's go back to IntelliJ. So we're going to get a stream of only the first element. Remember, this is now a stream of big integers. Okay? And also one thing, so let's actually break this up into multiple statements here. So we're going to take fact values dot, fact array values, and then we're going to do fact values equals fact array values dot limit 10, and then we're going to map here. So let's actually make this look just a little bit cleaner. So when you're working with stream methods, you're often going to have a huge cascade of method calls like this, and that's perfectly fine. So we're going to map BIP to BIP at 1, and then we're going to do toList. Okay? But of course, this is now a stream, so we need to convert this into a list. Okay? So now we can just print out fact values. So let's see, let's indent this correctly. Let's see what this looks like. So now we have 1, 1, 1, 1, 2, 6, 24, 1, 20, 7, 20, 50, 40. So I'm a little curious as to why this is doing that. So this is the factorial of 0, factorial of 1, but the factorial of 1 is 2, so we're offsetting something here. I think it might be because of this, but let's see. Maybe we should start both of these off at 1 rather than 0. There we go. Okay, yeah. So this is factorial of 0, factorial of 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is now 10 values that we've taken from the stream. Okay? So remember that if we just convert this into if we just have this map here, then none of these operations take place. So let's say we want 100,000 of these big integer factorial values. Okay? So this is now going to be a stream, because if we don't do .toList, none of this gets evaluated, and that's really important to realize. Okay? So yeah, so remember that these are called intermediate operations. So is iterate. Iterate's also an intermediate operation, because these return streams as results. Okay? If we want to actually force the results to do anything, then we can do toList, or we can collect them into some other type of data structure. Okay? So if we run this is going to take a while, because it's computing the factorial of 1 to 100,000, and that's going to take a while. So let's do 1,000 instead of 100,000. Let's just see what this looks like. So yeah, so this is astronomically large. So let's do factorial of 0 to 20. So now we have a stream of that many values. But theoretically, this represents a stream of infinitely many factorial values. Okay? So as an exercise, I encourage you to think about how you could replicate this to be a stream of Fibonacci values, or like an infinitely many Fibonacci values, or even do like the Collatz conjecture. So create a stream of all of the Collatz numbers for a given number, because it's unknown whether the stream, or not the stream, it's unknown whether every positive integer converges to 1 with the Collatz conjecture. Okay? But the main thing I wanted to show off here was iterate and .limit, and we just so happened to talk about .map. Okay? So in a later video, I'll actually really dive into why .map is kind of cool.